yourself next time.
Okay, thank you very much. It's a pleasure to be here. And my today talks will be about hybrid cloud with AWS. Firstly, please let me very quickly introduce myself. I work as head of development for Logistic Hub at Quest Technologies. Quest is Prague software house, and my focus is projects for logistic field. Especially our main client is DPD, and mainly DPD Czech Republic. But it's not only one client. We also cooperate with, for example, another DPD business units, another DPD countries across the Europe. But today's stories will be mainly about DPD Czech Republic. And how looks my team or my hub? In my hub are 4 teams. It's around 35 engineers. Okay, today I will talk about our story in DPD Czech Republic. So first I want to introduce some motivation, and then we will go deeper in some topics regarding to hybrid cloud. So it will be very interesting, and on the last part I will also summarize some pricing aspect of this tooling and also some hours best practices. So let's go deeper. Imagine some example. You are, for example, software house, and you just start cooperate with some big enterprise client. And how typically looks some enterprise environment? It's almost some environment where everything is on-premise with lots of legacy systems, with lots of databases, SFTPs, and so on. And at this moment, the company wants to innovate, wants to build new services, but some tooling, some ecosystem like Kubernetes is missing. So what you can do, or also what is important, what is very typical for many companies, that there are lots of free servers in this on-premise ecosystem, because these companies want to prevent some outages during peak seasons. So lots of free servers in this environment, and also it's typical that it's not easy to scale, or sometimes everything is only manual setup, so it's difficult to scale or innovate in this environment. So what you can do? One strategy can be use cloud. Of course, cloud has several benefits like scalability, flexibility, reliability, and so on. But from my perspective, it's also interesting the part regarding to manage services. Not only servers, but for example, some AI services or some streaming technology or some services for authorization and so on. But if you want to communicate with old legacy systems, you have to migrate this services into cloud, but it's sometimes very risky and complex and almost very difficult, almost out of the reality. So one of the strategies how to build something is use hybrid cloud. So basically just connect these two words together. The old on-premise ecosystem, it's some services from AWS. And in hybrid cloud approach, you have many strategies how to do that. One of them can be keep all services as is on the on-prem without some innovation or without some changing, because these changes can be very difficult, and build new services in cloud, in AWS, for example. And what is necessary to solve is some bridge, some transfer between these two data centers. But also try to remember on my point with many free servers. Imagine that it's significant amount of free servers on premise. So one of the challenge what is good to solve is try to reuse these servers. So you can just set up some tooling that will be compatible with this hybrid cloud environment and reuse these servers. This point is optional for hybrid cloud solutions, but my today's presentation will be lots of about this topic. And this example wasn't some hypothetical scenario. It was a real example with our cooperation with DPD Czech Republic. So if we started cooperate with DPD, we just had some free servers with SSH connection, and we ran a first service with PM2. And very quickly, we tried to build something better. So we use some AWS container management tool. I will talk about it into more detail later. And we built several services cloud native, and then we implemented several aspects in this hybrid cloud solution, like monitoring and some networking connection. And right now in the production there are more than 100 services. So it's a real example from our experience. And what is interesting that we don't have DevOps, someone for full-time who only manage infrastructure. Everyone is managed by developers. So what you can use if you want to manage containers with AWS. Basically, AWS offers two features or two services for managing Docker containers on-premise. First is ECS Anywhere. It's basically Kubernetes Anywhere. Of course, Kubernetes is very strong platform where everything is solved. So for many teams, it can be definitely the best choice, but the weakness or negative aspect can be that it's a higher operation complexity. It's not easy to set up, and you need more skilled people in your team for manage that. The another way is ECS Anywhere. It's more lightweight tool for manage Docker containers on premise with AWS. It's very, very easy to set up, but it's only container management tool. So in this tool is not for example, something for load balancing or proxies. So you had to build it with yourself. And also it's more connected to AWS, so it's easy to migrate to another technology later if you want. But our choice was ECS Anywhere for reason of simplicity mainly. And this tool helps us to reuse on-premise services, but with AWS tooling. And how it works, or how you can use it, it's very simple. You just need AWS account and server with sudo access. And in AWS, you just create some activation key, and then into your server, you just install a few commands, and these commands will install two agents, SSM agent and ECS agent. SSM agent, it's more a low-level system service. that basically capture some metrics and logs from the system. And also, this SSM agent can help you with connection from AWS into your server. You can use this agent for remote connection from AWS console. So basically, it works very similar like SSH. And second agent, ECS agent, it's a more high-level agent. It runs as a Docker container, and it basically manage your Docker containers. It's the same logic like classic ECS. And if you install these two agents into server, you just can define your application and use it in the same approach like with classic ECS. So now I will show you in some quick demo. So if you have AWS account, you just need to create ECS cluster. Just fill name. Everything else can be default. It takes some time. And then you can go to the ECS cluster, especially infrastructure section. And as I mentioned, now we need to create activation key. You can set some expiration time. And that's it. This button generates command for Linux-based servers or for Windows-based servers. And this is my example server, Linux-based. I need to use sudo and just paste this prepared command, and it's everything. And after this installation, will be installed SSM agent and ECS agent. So this one-liner is enough for connect your server with ECS, with AWS ECS. And if I try to list my active Docker containers, it will be possible to see that ECS agent is running. And right now I can explore my ECS. It's possible to see this external instance. And SSM agent right now can help me to explore some metrics from the system. So, for example, I can go to the file system section where it's possible to see all directories from the remote server. I can explore some metrics or information about processes or users. So it can be very helpful for some use cases. And this feature can help me go into the server with help of SSM agent, and I can manage server with same approach like with SSH. So sometimes it can be also more with better developer experience than SSH. And now very quickly, let me show you how to create some services that will be operated in on-premise server. So I prepared simple engines, and right now only thing is use external types of instance, and that's it. Right now the service is in the progress of the starting. So I can go to my server, and if I try to list running containers, after some time, yeah, I can see Nginx is running. So it was very simple approach how to run this container, and now I can explore some data, but better will be generate some requests against to Nginx for capture some logs, metrics, or traffic in general. So now it's possible to see some logs. So this logs was captured from my on-premise Docker container, and with the help of CloudWatch, I can explore that. And in ECS, I can set up everything same like in classic ECS, so auto-scaling, for example, or I can explore some deployment infos. And maybe last good thing is metrics. I can explore RAM, CPUs, and other from my Docker container. So in this demo, I showed you that installation of ECS agent is very, very easy. Less than 5 minutes, and you can use your on-premise server for hybrid cloud approach, we can say. But imagine that we solve only one part. We just run some services on-premise, but then it's very easy to use some AWS classic cloud-native services or features. But if you want to connect these two worlds together, you need to solve some networking transfer challenge. And basically, you have three ways how to do that. First is basically do nothing and just use public internet. So, for example, communicate over HTTPS. It's easy to set up, or with no setup, we can say. But the latency is higher and it's less secure. Another option is site-to-site VPN. So basically, IPsec tunnel that is between these two data centers. It's more secure, but with limited bandwidth, and also with comparison previous, it's more expensive. I will show later some details of pricing, but definitely this is a good way. And last alternative, the most preferred by AWS, is Direct Connect. It's basically a real physical connection between these two data centers. So you need physical connect some cable, some wire into your data center. But the benefit is that latency is much more lower, and it's stable. It's basically some dedicated bandwidth for you. But it's very expensive, and it's not easy to set up it. And it's related to our story or our example. We started with public internet, and then we try to use AWS Direct Connect. But unfortunately, after several months of basically communication between on-premise provider and AWS, it wasn't possible to do that because some hardware issue, incompatibility between on-premise data center and AWS. So after some time, we switched to site-to-site VPN, what is our current solution. Another point, what is necessary to solve if you are using some on-premise servers and ECS Anywhere, is some load balancing or proxies issues. This topic can be solved with many strategies. This is our strategy or our solution. We use certificate manager with CloudFront for SSL termination and for certificate management. From my perspective, what is benefit of certificate manager, that it very easily manage automatically HTTPS certificate with automatically refreshing. Another layer is hub proxy. It's a main entry point for our infrastructure. It performs load balancing, health check, and it can filter some traffic, for example, IP-based. And we are using traffic as internal routing layer. It helps us register and deregister new services based on Docker labels. So basically, if we release new services, it's necessary to use Docker labels. Docker label are detected by traffic, so traffic knows everything about each container, the specific host and port, and proxy just balanced based on host name to dedicated cluster name. Another important point in hybrid cloud is observability, monitoring, alerting, incident management. We are using Grafana Stack. Grafana Stack helps us to capture metrics, logs, traces from all part of the hybrid cloud, so from cloud native and also from the on-premises. We are using Prometheus for receiving metrics from task container, and also Jaeger, or now, because Jaeger is deprecated, Grafana agent for traces. And these traces and metrics from Prometheus are pushed into Mimir and Tempo. It's something like backend of our monitoring stack, and together with Loki, that is basically backend for logs, is a data source for Grafana. And maybe another interesting point is that metrics can be generated also from some infrastructure component like traffic, proxy, and also metrics are generated from the Tempo. Tempo analyze each trace, and from each trace are generated metrics. It helps us, for example, very easily monitor GraphQL queries or mutation, because it's a part of the trace. And also these traces works in a distributed way, so you can trace requests from example from cloud native service that call on-premise service, and this service calls another service. Everything can be connected together with trace ID and explore in one window. So I think it's very powerful. This is some very easy example, some dashboards that can combine more data source, Prometheus that, for example, helps us show some data about GraphQL, like latency or request per second. And on the left side is some logs from Loki that filter, for example, errors, logs with errors. And on the right side is some data from Tempo. It's slowest traces, slowest request. And this is another example. It's our dashboard from NUTS. It's our streaming technology. And it's very good that if you are using Grafana Stack, lots of services or technologies are automatically prepared for it and generates, for example, these metrics. And these metrics are easily connected into your Grafana Stack, and you have for free, basically, without some setup, prepared dashboards. And this is some example of trace. So you can explore request, for example, step-by-step trace of your request that can include also database call, for example. So now let's explore a little bit pricing section. In hybrid cloud approach, the most significant part of the pricing is ECS Anywhere agent itself. The cost is around $7 monthly per instance. So if you have, for example, 10 servers, you need 10 ECS agent, and it costs $7 per instance, so $74 monthly. Another part is data transfer. If you upload something to AWS, so sending some data from on-premise to AWS, it's free. The problem is another way, download from AWS, and it depends on the type of your data bridge. If you are using public internet, first 100 gigabytes are free, and then it's $0.09 per gigabyte. If you are using IPsec tunnel or VPN, it's two parts of the price, first for tunnel and then for gigabyte. And last is direct connect. It's much more expensive with comparison of VPN for tunnel, but for traffic per gigabyte is better. The price is not fixed because if you want to use direct connect, you need to call AWS support, and it's a process of communication and negotiation, we can say, where it's necessary to prepare hardware compatibility, for example, and also discuss some predicted traffic workload, and based on this, AWS send you some offer for price. Last section, it's basically some summary with our best practice and tips. First, what I think it's important, version everything. We are using infrastructure as a code with technology AWS CDK. CDK, it's cool technology. It can help you build infrastructure in many programming languages. One of them is TypeScript, what is also our programming language for DPD Czech Republic. So we have everything in TypeScript, and it's easy for us to keep the infrastructure as a part of the Git repository, so we can create pull request with editing infrastructure, code review, and then automatically deploy to each environment. Then I think it's important. Observability, as I mentioned, our Grafana stack is very cool and is good to connect everything in the same approach, cloud native and also on-premise services. And if you have this Grafana stack, you can easily create some alerts, and based on alerts, prepare some incident management process. We are using PagerDuty for incident management, so some Grafana alert trigger PagerDuty, and we have on-calls, so if someone has on-call, it's triggered by phone ringing. So it's good to have this centralized observability stack. And the related, maybe a little bit controversial point is regarding to logging. Our tip or our our use case is log every request or almost every request. It's definitely very expensive or can be expensive in some heavy service, but the speed of troubleshooting or solving some bugs for us is very important. So we log almost everything, and each log should have trace ID, and this trace ID can be used in the Grafana, and based on trace ID is possible to explore trace, so request flow. And next point is regarding to some developer experience. We prepared, for example, example project. And in this example service is every aspect prepared, like CI/CD, infrastructure, some architectonical patterns, and so on. So it's easy to just extend and deploy some API, for example, very quickly. And it's not only about example project. We prepared lots of tooling into some common service for easily sharing some utilities. And as I mentioned, direct connect can be sometimes challenge. It was 5 years ago, so maybe right now it will be better and we can try it again, but it was blocker for us. And last point, from our experience from on-premise world or in hybrid cloud approach itself, is that managing something, it's sometimes very difficult, because the comparison with cloud native world is that it's necessary to create maintenance, backup, or create everything in with some redundancy. So it can be challenge, and if you want to choose between cloud native service or managing something on your own, I think that right now I will always support cloud native solution. So that's all, and thank you very much.